So in the previous video, we learned how to calculate a probability defined by inequality like this, and we consider 21 n equals 21. So now the parameter is previously parameter was 22 and 0.9, but now this becomes n becomes 21 because it's the number of reservations you accept, but we assumed it equals 21. Then probability greater than 20 is simply one value, 21, right? Because maximum is 21, there is no other possibility. So you sold 21 tickets, and the problem is only when all of them came to the airport. And its probability is simple. Use the formula 21 chooses 21, and 90% happens 21 times, and nothing for 10%. If you do the math, this is 1, and if you calculate this, it will be 10.942%. Right? It's a simple exercise. I just want you to show you. I want you to practice how to calculate inequalities. And using from the result, what's interesting here is as you decrease the number of reservations, number of trials from 22 to 21, you decrease it by only 1. It's less than 5%. But the probability of the problem changes to less than 1/3. It was about 34%, but now it's only about 11%. So again, a binomial distribution is not that intuitive. It's the actual numbers are quite different from what you can expect with the given numbers. So it's not simply obtained by combining some numbers from the questions. So that's why binomial distribution is important. It's a very realistic example, and also very interesting, but not that easy. You may think it changes this change will make a small change, but actually not. It's a huge difference in the end. Okay, we will consider one more example. This is the last example in this slide. It's about quality inspection. I'm showing you this example because I will use this example again later in chapter 9 or 10. So 9, maybe 9. Let's think about this story. Suppose that your firm, you have a factory manufacturing batteries. And suppose that the battery is defective with 5%. So your battery may explode or may not work with 5%. And you supply those batteries to another firm, and the client screens the quality of the batteries upon reception. So when you ship your batteries to the client randomly choose 10 batteries out of your shipment and inspect them carefully. And they are going to accept the shipment only if 2 or fewer batteries are defective. So when inspect 10 batteries, if 3 batteries are defective, they are going to reject your shipment, right? That you understand? Then in this case, I am going to define y, or random variable y, as the number of non-defective batteries, good batteries, quality batteries from the inspection. And out of 10 inspected batteries, y is the number of non-defective ones. Then what is the probability that your batteries are rejected? Think about this. Answer this. I will turn to the next page. 3, 2, 1. This. So also it's a little bit very tricky because you have to think about the inequality in different ways. First, what I told you is batteries are accepted only if 2 or fewer batteries are defective. So this means your batteries will be rejected if 3 or more batteries are defective, right? These two are the same sentence, and that means your batteries are rejected if 7 or fewer batteries are non-defective. I'm switching the sentence to this way because Y is defined as the number of non-defective batteries. So I would like to write a sentence in terms of non-defective batteries, and we are interested in the condition for rejection. So the probability of rejection is when Y, the number of non-defective batteries, is 7 or smaller, right? Smaller than or equal to 7. This is the answer. Answer is E. Okay, it's if you just think it step by step, it's easy. Then now think about the parameters. Parameters for Y. Clearly, Y is a binary variable, and the maximum number is 10 because when 10 batteries are inspected, the maximum possible number of non-defective batteries is obviously 10 because only 10 are inspected. And probability of a non-defective battery is 95%. Remember, we are counting non-defective batteries, so P has to be the probability of non-defective batteries, right? So 10 and 0.95 are the parameters for the binomial distribution. So we are ready. We found the probability we are looking for, and we found the parameters. These two are the first steps to consider any uh, binomial distribution questions. Okay, now let's calculate this probability. This probability is defined as by an inequality. So in principle, you have to calculate probability Y is smaller than or equal to 7, which is 7 or 6 or 5 or 4 or 3 or da 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 to 0. This is not a clever way because you have to calculate 8 probabilities. You have to apply the binomial distribution's probability 8 times. It's not a smart way. Instead, I would calculate this probability. You are calculating the probability of Y smaller than or equal to 7. But instead of this, I would calculate. So this is probability of rejection. But an easier way is to calculate probability of acceptance and take the other side. It's a complement rule. So if you know probability of acceptance, automatically 100% minus probability of acceptance is probability of rejection. So the probability of acceptance is more convenient to calculate because there are only 3 cases. Probability Y equals to or greater than 8 contains only 3 possible values, 10 or 9 or 8. So you apply binomial probability formula only 3 times. If you take the first step, you have to do that 8 times, but now you need only 3 times. So obviously, the second method is a better way to calculate the probability. Just use the formula. I'm not showing the details. Then 100% minus 3 probabilities equals to only 1.15%. So the probability of rejection is only 1.15% given these parameters. So this is the end of the slide. And to summarize, what we derived the probability formula, which is the most important idea in this slide. And using that, you can calculate mean and variance, and their formulas are pretty simple. Also, you can calculate probability defined by inequality. The idea is simple. There is no direct way to calculate inequalities. You have to break down the inequality into multiple single outcomes. Okay, in the next chapter, we are going to study a totally different parametric distribution family. So, I look forward to that. See you in the next video. Bye.